Okay, when an aqueous solution of ethanoic acid reacts with magnesium, the progress of the reaction can be followed using the equipment shown in Figure 5 to measure the volume of hydrogen produced. So we've got a gas syringe, we've got ethanoic acid, we've got a magnesium metal, we've got a bung, we've got a test tube. Figure 6 shows how the volume of hydrogen produced varies with time when 396 milligrams of magnesium are added to 30 centimeter cubes of zero point 0.6 mole per decimeter ethanoic acid. You know what I like to say? I like to say highlight the stuff. So I'd be highlighting this and going, right, that's mass. Soon as I know that that is mass, you're probably at some point in this going to want to do mass over mR times moles. That's the crustiest little triangle you've ever seen. And then you've got volume there, haven't you, centimeter cubed, and you've also got concentration. And that generally means you're going to at some point need to do N over C times V. There we go. So this is an amount of substance question. As you can see, we've already identified the key points. Let's get down and check out Figure 6 and see what the actual command of the question is. So here's Figure 6. We've been given the volume of a hydrogen. We can see that's going up over time on the x-axis, and then it levels off at a certain point. Okay, 8.1, the equation for the reaction between ethanoic acid and magnesium is shown. We got 2 moles or 2 molecules of ethanoic acid, aqueous plus magnesium solid goes to magnesium ethanoate and hydrogen gas. With the AIDA calculations show that magnesium is in excess in this reaction. So what I want to do is focus on those bits. So we've got the magnesium, the mass, and we have the volume and the conch of the ethanoic acid. So why don't you pause the video, have a go, and then unpause and watch me go through the answers to this. Okay, here we go. So with the AIDA calculations, basically we need to do mass, 396 milligrams is the mass. Bearing in mind we need to convert that to grams, so it's actually divided by 1,000, you get 0.96 grams. We're going to divide that by the MR, and that's the magnesium. The MR or AR in this case, because it's not a molecule, is 24.3, and that is going to give me my moles of magnesium. Now, I'm going to write this down as 0.01629, and that is the moles of Mg. What I need to do now is work out the moles of ethanoic acid. So in order to do the ethanoic acid, we were given the volume. Now, I believe the volume was 30 centimeter cubed. We need to change it to dm. So we're going to divide by 1,000 and we're going to times our volume by our concentration. And the concentration was 0.6. All right, it was 0, but it's the same thing as saying 0.6. And that was mole dm minus 3 or mole per dm, there we go. And that's going to give us my moles of ethanoic acid. And the moles of ethanoic acid are 0.018. So at first glance, my moles of ethanoic acid, remember what's the formula for ethanoic acid? It's CH3COOH. So I've got my moles of ethanoic acid, and at first glance, you go, oh, 0.018. The magnesium, we've got less magnesium. That's the limiting reagent. But they've told us that magnesium is in excess. Well, how can it be in excess if we've got less moles? Well, what we need to do is come up to the equation and see that we need 2 moles of ethanoic acid for every mole of magnesium. So we can show that the magnesium's in excess and that we have left over, because what we can do is we can say, well, how much magnesium do we need to wipe out this 0.08? Well, as the ratio between Mg and ethanoic acid is 2 to 1, or 2 ethanoic acids to 1 magnesium, I can say, well, I've got 0.018 magnesium, so how much ethanoic acid, how much magnesium do I need? Well, divide it by 2. And that's exactly how much magnesium you're going to need. And I only need 0.009 moles of magnesium. And I've got way more than that. I've got 0.01629. Another way of us doing this to show that the magnesium's in excess, another calculation we could use to show it's in excess is we could say, well, how much ethanoic acid do we need? Well, if I've got 0.01629, I could times that by 2 and say, in order to use up all that magnesium, I would need 0.03258, but actually we've only got that. So that's how much ethanoic acid you would actually need in moles, and we don't have that. So again, there are different ways. 8.2, the reaction was repeated using 20 centimeters. So remember, they used 30 at 0.6. So we're going to 20, a smaller volume, but a higher conc. So how do we know that? Well, look, um, they used original was 30 centimeter cube. That's a higher volume. It's about 50% higher, isn't it? 30 centimeter compared to 20. And the original conc um, was 0.600, so like 25% less than the new conc. So we've got a lower conc and a higher volume. So what we want to do is we're going to look at, okay, so we've been asked to draw a new line for the new concentration. So the original ethanoic acid was 0.6 as the conc times the volume of 0.03, and that gave us 0.018 moles. And that told us roughly the moles are equivalent to what was the ratio of ethanoic acid to hydrogen? Let's check it out. Where's the damn equation? There it is. So it's a 2 to 1. So essentially, we're going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. So we're making 0.09 moles of hydrogen, right? Because it's 2 to 1 with the hydrogen. You get the idea. Anywho, that's how much hydrogen gas is coming off there at this point. However, they've told us that they're changing the conc. What are they doing? They're increasing the concentration. But this time they're doing 0.08 times 0.02, and we can work out the new moles of hydrogen, and that is going to be 0.016 moles. Now, as it's 2 to 1, the ethanoic, that's the moles of ethanoic acid, but it's 2 to 1 with the hydrogen. We're actually this time going to finish here. We can only make a maximum amount of 0.08 moles of hydrogen. So I know my line's going to finish there. However, the concentration is higher here than it is here. And that means there's more particles in the same space. So we've got more reactant collisions, we've got a faster rate of reaction. So I want a steeper line, but a line that then plateaus and ends here. I can't make any more than that because my limiting reactant is the hydrogen, and I have less moles of hydrogen than I did originally. So I want to be about 1 square down. Coolio. Hope that helps. Don't forget sharing, caring, hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.